Hello students, this is the Quantitative Reasoning Unit 2 Concept 3 review. We're going to be taking a quiz on this tomorrow, so take a look at these different types of sample review questions. The first one is simple probability. A student picks a colored cube from a plastic bag, 5 green, 6 red, 3 yellow, and 5 blue cubes. Keep in mind it does have a 5 here, even though it's spelled out in letters, that's the number 5. What's the probability that the student picks one green cube? So it looks like these are all the different cubes that are in play here. We got 5 plus 5 is 10, and 6 is 16, 19, so there's 19 cubes in total. So the question is asking for a probability that the student picks a green cube, and probability is a fraction with the denominator being all the possible choices and the numerator being all of the desired choices. So if we're looking for the probability of one green cube, we put capital P, parentheses, one green cube. And the desired outcomes, well, there's 5 green cubes for sure. And there are 19 possible cubes that could be drawn. So 5 divided by 19 is our answer. Now it looks like this fraction cannot be simplified. 5 and 19 don't have any factors in common. They're relatively prime. They're actually both prime numbers. But if you could simplify it, that's fine. You don't have to on the exam. You can leave it as whatever it is. For example, if it's 5 out of 20, you can leave it as 5 out of 20. You don't have to simplify it 1 over 4. All right, for multiple events, Hazel rolls 2 dice. What's the probability that the first die and the second die are both 6? So you know that dice look like this, and there's 1 6 on each die. So the probability that the first die lands on a 6 is 1 out of 6. And since the dice are pretty much exactly the same, the probability of the second die being a 6 is also 1 out of 6. So as the problem itself tells you, these are multiple events. So the first event and the second event have their own probabilities. But in order to figure out the probability of the whole thing happening, all these multiple events happening, we have to multiply. So multiplying both probabilities, 1 over 6 times 1 over 6, we get 1 over 36. So the probability that they are both 6s is 1 out of 36. Multiple events, so we take the individual probabilities of each individual event and multiply them together. Next, Jaime uses the tree diagram at right to represent the following scenario. This person has 2 dimes and 3 pennies in his pocket. He picks 2 coins, one at a time, without replacement. And that without replacement means he doesn't put them back. And we can see that it is without replacement because the first choice is picking a dime. That's 2 out of 5. And so if he does pick a dime first, the second pick of a dime is only 1 out of 4, which means there's only 1 remaining dime out of the 2 dimes that were there. And there's only 4 coins left out of the 5 coins that he started with. So let's go through and try to figure out which outcomes give me 2 different coins. Okay? 2 different coins, right? So let's see. This first outcome is dime, dime. So that is no good. That is not what we want. That is not 2 different coins. And similarly, we have penny, penny down here. That is not what we want. That is not 2 different coins. But we do have dime, penny, which is here, and penny, dime, which is here. So we need to find these 2 probabilities and add them together. So this outcome, which is first dime, then penny, is 2 out of 5. Probability for dime, 3 out of 4 for probability of penny. Again, it's multiple events, so we take these numbers and multiply them. 2 out of 5 times 3 out of 4. So when we multiply across, we get 2 times 3, which is 6. Those are the numerators. And then 5 times 4, which is 20. And now we'll find the probability of penny, then dime. That's 3 out of 5 times 1 out of 2. So I do numerator times numerator. That's 3 times 1 is 3. 5 times 2 in the denominator is 10. So the probability of picking 2 different coins is going to be these 2 different probabilities that we found. We found 6 out of 20. That's first dime, then penny. And a 3 out of 10. That's first penny, then dime. 6 out of 20 and 3 out of 10 added together is going to be our answer. If you do that on the calculator or if you simplify this to 3 out of 10, either way, you're going to get 6 out of 10. Okay, so we're done with number 3. Number 4 is constructing a Venn diagram. Nancy's got 100 people, asked about what type of car they drive. It's either Honda Civics, silver cars, or both. Tells me that 58 drives Honda Civics, 65 drives silver cars. How many people drive silver Honda Civics? So the question is really asking how many people drive silver Honda Civics It's looking for all of the things in this area here. We know that there are 58 people driving Civics, 65 people driving silver cars, and when you add those two numbers together, you get 123. That's a lot. 123 is more than 100 for sure. So what we have to do is we have to figure out, well, how much over that 123 is from 100. Well, 100 subtracted from 123 is 23. So this amount of double counted students, or double counted people who are drivers, rather. So now we can replace this with 23. And last but not least, since we know there's 23 here, we can do 58 minus 23 to get the number here, and then 65 minus 23 to get the number here. So we have 35, 23, and 42. And when you add these three up, well, guess what? You get 100. Great. Moving on to question 5. Catherine goes to Subway. She gets the whole wheat bread 60% of the time, sometimes get the Italian bread 40% of the time. She gets turkey and vegetarian, that's 70 and 30. And then for dressing, Chipotle Southwest, mayonnaise, or balsamic vinaigrette. So it seems like there are 3 different events here. We have one event which is type of bread, one event which is type of sandwich, and then one event which is type of dressing. So this is what it's going to look like when it's all built out. Let's explain why. The first event, like we said, is whole wheat bread versus Italian bread. So whole wheat versus Italian is this first split. It's either whole wheat at the top or Italian at the bottom. And we're going to put the probabilities onto the tree diagram in decimal form. So we have whole wheat bread, which is 60% of the time, and Italian bread, which is 40% of the time. Next, well, that first event was bread. The next event is choice of type of sub. It's either turkey or vegetarian, so it's going to look like this. So you should be able to see turkey and vegetarian. And notice that they're the same probabilities on top and bottom because it doesn't matter what type of bread, whether it's whole wheat bread or Italian bread, there's still the same probabilities of getting turkey or veg either way. Okay, last but not least, event number 3 is type of dressing. And again, when you're looking at the different dressings, Chipotle is 0.7, 70%, mayo is 0.2, which is 20%, and balsamic vinaigrette is 10%, 0.1, regardless of the type of sandwich or the type of bread or anything like that. They're independent events. Okay, so if we wanted to, we could take this tree diagram and use it to figure out probabilities. Let's say the probability of getting a whole wheat bread turkey sandwich with Chipotle dressing. But it didn't ask us to do that. It just asked us to construct the tree diagram. So it may be on the quiz, you're asked to make the tree diagram and then calculate some probabilities. I showed you that one example here. Feel free to pause the video and review how to get these values. But otherwise, we will continue with the review. All right, moving on to expected value. Consider a game in which you pay $5 to flip a coin. If you get heads, you earn $10. If you get tails, you don't win any money. What's the expected value of the game? Should you play? Okay, so expected value, as you know, is the probability of each outcome times the profit for each outcome. So there are 2 outcomes here. It's either heads or tails, and each of them have a different profit. So this first probability and profit in red is 1/2 because it's the probability of heads, and then 5. Well, it says if you get heads, you earn $10, but you're earning $10, but you already paid that $5 to flip the coin. So 10 minus 5 is the profit, which is 5. And then for tails, it's a 1/2 probability of getting tails. And this -5 represents the fact that you paid $5 to flip the coin, but you didn't win any money. So the profit is -5. So when you do the math, 1/2 times 5 plus 1/2 times -5, those are opposites, additive inverses, so they eliminate and give you 0. So the question is, should you play? If the expected value of the game is 0, that means an average play of the game is going to get you $0, which means you're not going to be losing or gaining any money. The question is, should you play? You're not earning or losing any money, so the answer is no. The only reason that you would play a game like this, a game of chance, is if the expected value is positive. So the answer is no, you should not play. All right, last but not least, Alejandro rolls a fair die. In 400 rolls, how many times would Alejandro expect the die to come up with a number larger than 4? Well, first let's find the probability of rolling a die and getting a number larger than 4. Well, on a fair die, there are only a couple of numbers larger than 4. There's a 5 and a 6. So we need to calculate the probability of a 5 or a 6. So now the probability of getting a 5 or a 6 is 2 out of 6 because there's 2 desired outcomes, 5 or 6, divided by 6 possible outcomes. So if I'm doing 400 rolls, how many of those rolls should be a number larger than 4? Well, remember, with expected number, we're multiplying the probability times the number of trials. So it should be fairly straightforward to multiply 2 over 6 times 400. Well, it turns out that 2/6 times 400 is equal to 800 over 6. That's the same as saying 133.3 repeating. With expected number, we're really looking for a number. So in this case, we're talking about 133 times that we expect Alejandro to come up with a number larger than 4. All right, that was the review sheet for the Unit 2 Concept 3 quiz. Good luck studying.